Good morning, Shiva. How are you? So firstly, make sure the screen is visible to you and I'm audible to you. If it is so, then put a message in the chat box as soon as possible. Okay. Okay, so here we are with our question discussion on KTG and thermodynamics part 4, and this will be the last session on KTG and thermodynamics. The concept that I have covered and that is not been covered in the regular classes will be covered in this session and will have been covered in the previous sessions also in the numerical form. So nothing will be coming out from this. I think it is sufficient for any examination if you are aiming for JEE and NEET. Both for both it is more than sufficient, I think. So today also we have some conceptual question and some PYQs from JEE and NEET. So we are going to discuss them one by one, and more of the weightage would be on KTG because thermodynamics we have done various questions. So more of the weightage will be from KTG, kinetic theory of gases. And I hope you remember that in the previous session that is held, I think couple of days ago. So I have give you a one numerical problem for homework. I hope you remember. So have you solved it or not? Because it's long time that I'm seeing you. Okay. So one of the thing that I have to discuss with you also, we'll be discussing in on later on the classes. Okay. Now, is anyone joining from your school? Anyone else? Okay. So we should start the lecture now. So this is the first question on your screen, and this that was the homework that that I have given to you. Hope you remember it. So the question says that 5.6 liter of helium gas at STP is adiabatically compressed to zero point 0.7 liter. Taking the initial temperature to BT1, the work done in the process is. Okay. So try to solve this question and I'm giving you 1 minute to solve this. 1 minute is required to solve this question, not more than that. So try to solve this question. Helium gas is given to you. Remember that helium gas is a monoatomic gas. Okay, so several gases like very familiar, very common gases that we put in the numerical is hydrogen, helium, neon, argon, oxygen, chlorine. So these for these types of gases, all the inert gases and halogen group gases and oxygen and hydrogen. So these gases, you should remember that either it is monoatomic or diatomic or polyatomic. Okay. So all the inert gases, helium, neon, argon, krypton, xenon, these are all the monatomic gases. If you talk about hydrogen, you always write hydrogen as H2. So H2 hydrogen gas is the diatomic gas. Same goes for oxygen. This is also for O2, diatomic. And if you talk about chlorine, fluorine, so chlorine is Cl2, remember? So chlorine is also a diatomic gas. So these types of gases, you should know about the data of these gases, either it is monoatomic or diatomic, because Not every time you will get in the question that, because like in this question, it is not mentioned here that helium is monoatomic or diatomic. Okay. Okay. So your answer is 9 by 8 RT1. Okay. So let's solve it and see how it goes. So first of all, what is given to us that 5.6 liter of helium at STP, any standard temperature and pressure. Okay. Standard temperature and pressure. So V1 is given to you as 5.6 liter. Okay. Then V2, because it is compressed adiabatically. Adiabatically, which means this is a process in which there is no heat transfer into the boundary and out of the boundary. Or you can say there is no heat transfer to the system and from the system. And same goes for surrounding also. So zero point 0.7 is the final volume that we have here. Now, initial temperature we have to take T1. This is the initial one. Final temperature has been asked. T final is the question mark. Now, this is the adiabatic process. So, general equation we know for adiabatic process for, and try to note it down if seems important to you, try to note it down. If for adiabatic process, the general equation that we know is in terms of pressure and volume, PV raised to the power gamma is equals to constant, where gamma is the adiabatic index, depends on the atomicity of the gases. That is, it is monoatomic gas or diatomic gas or polyatomic. So gamma will depend on that. Okay. But the another relation, because here the the required relation is between volume and temperature, because these two terms are given to us. So we need to convert it into volume to temperature. Okay. So we can also do it by engaging the ideal gas equation, PV is equals to RT for 1 mole of gas, and we can do the calculation from here. But the direct relation you can keep in your mind is that we know that at constant volume, pressure is directly proportional to temperature. So we can say that temperature here, TV raised to the power gamma minus 1 is equals to constant. This is also the relation for adiabatic process. Now, if you put the value according to it, it will be T1 by T2, V2 by V1, because this is the inverse relation it is following, gamma minus 1. Now, T1 is T naught, oh sorry, T1 is T1 given to you, initial temperature. T2 we are interested in, which is T final. V2 is zero point 0.7 because it is compressed, so volume will decrease 0.7, and initially it was at 5.6 liter. Okay, don't need to convert it into meter cube and all, because this will automatically cancel out. Now, helium is the monoatomic gas. This is monoatomic. So if it is monoatomic, the CV, constant specific heat CV, is 3 by 2R. Always remember, for monoatomic 3 by 2R, then add 1. For CP, add 1 into this. It will become 5 by 2R. Same if it is diatomic, so start from 5 by 2, then add 1. Okay. Now, why I'm discussing that? Because gamma here is nothing but CP by CV. You can also directly learn the values of gamma for monoatomic, diatomic, and polyatomic. Okay. But you always know the concept behind it. The Cp by Cv, you can put 5 by 2 upon 3 by 2. So 2 and 2 will cancel out. It will become 5 by 3. Okay. So you have to put here gamma minus 1. We can say T1 minus T2, T1 by T2, sorry, is 1 by 8, because 7 8 ja 56. Point and point will cancel out. 5 by 3 minus, it will become 1 by 2 raised to the power 3. 5 by 3 minus will become 2 by 3. So 3 and 3 will cancel out. Got it? It will become T1 upon T2 is equals to 1 upon 4. So final temperature T2 we have as 4T1. Now, what has been asked? The work done has been asked in this process. So we know that work done uh, in adiabatic process in terms of temperature is NR, or should I write it on the next page? So work done will be in adiabatic processes NR T2 minus T1 divided by gamma minus 1. Now N is 1. Ideally, we will take 1 mole of gas. Now, so R T2 is, we have got 4 T1. T1 is T1, so it will become 3 T1. Gamma minus 1 again, 5 by 3 minus 1. So it will become 2 by 3. R into 3 T1, 5 by 3 minus 1 will become 2 by 3. So this will go up. It will become 9 by 2 times R T1. So how we will go 9 by 8? It is 9 by 2 RT. You have made some mistake, I think. Yeah, I think you have plus it, na? Or let me check. Just a second. Let me check whether the work done I am getting wrong or not. Just give me a second. Yeah, it's absolutely correct. Work done will be 9 by 2 times RT. So I think you have made here gamma plus 1. Okay. So make it correct. Otherwise, you are totally correct. This silly mistake you will not do. Oh, I hope you got this. Any kind of doubt in this question? No? So if any doubt will occur, you can put it in the chat box. Now move on to the next question. Got it. Have you understood where you have make the mistake? It's not gamma plus 1, it is gamma minus 1. Okay. Yeah. And in the previous session, I have told you that the work done will be coming out negative because it is NR T1 minus T2 by gamma minus 1. So T1 we have T1, T2 we have 4 T1. So it will be minus 3 1. So I have told you that take the mode of that. Okay. Okay, no problem. You got it. It's wonderful. Now solve this question. This is also very important question, and these types of question has a tendency to be asked in the nowadays. Okay. Hello, student of JNV Anand. Good morning. Now try to solve this question. So an ideal monoatomic gas undergoes a process in which its internal energy depends on its volume as U is equals to A root V. This is the relation given to you in terms of volume. Okay. So what you have to do, you have to find out the work done by the gas and heat transferred to gas. Increase the internal energy by 200 joule. And second, what you have to find out, molar specific heat in the process. Okay, so giving you 2 minutes to solve this question. At least you think where you should go in this question. Okay. So the relation is given to you. Increase in the internal energy is also given to you, and work done you can calculate, and it is also given to you that this is the monoatomic gas. Okay, so try to solve this question. So JNV Anand, I'm audible to you or not? The screen is visible to you. Try to solve this question if it's so, and if it is not, just let me know. Okay, I'll start solving it after 2 minutes. I'm giving you the time, so take your time. Apply the concept that you have in your mind, that what you can do with this, the relation of internal energy and V, the term monoatomicity. Okay, these types of question came up with a conceptual clarity in your mind. Okay, and if you're clear in the concept now, you will ace any type of numerical. Okay, that exam fear, what kind of question will become, that is vanishes, that will vanish. Okay, and yeah, I hope that Shiva, you will definitely do better in your life, because the one thing that is required in a student, which is punctuality, discipline, that is present in you. Student of JNV Ramnagar and other students also, but specifically you, I'm saying, no offense to other peoples, but you are too good at punctuality and discipline. Okay, so let me just solve it. So here the ideal monoatomic gas is given to you, and the relation is given to you as U is equals to A root. Okay. Now what we will do, we know that U here is the internal energy, which is given by NCVT. I'm not writing delta T because it is specifically U, not delta U. So that is why I'm writing it NCVT, A root V. Now CV you can write for monatomic gas. For monoatomic, CV is equals to what? 3 by 2 times. Okay. Hello, student of JNV Bhavnagar. How are you? So CV we have 3 by 2 times R T A root V. Now you can take 3 by 2 as this and write it as nRT A root V. Now we know that from ideal gas equation. Ideal gas equation says that what is the meaning of ideal gas equation? PV is equals to nRT. So you can put this value PV here, 3 by 2 times P into V. Why we are focusing more on PV? Because work done term is given, and we know that work done is P dot dV. Okay, so that is why we are finding the pressure and volume relation. Now you can say that it will be P root V 2A by 3. This is equation number 1 that we got. Okay, so according to us, or according to this question, the pressure and volume relation in this process is P root V equals to 2A by 3, or P root V equals to constant, you can say. So the gas will undergo according to this process in terms of pressure and volume. Okay. Now, we can also say that is given to you that increase its internal energy by 200 joule. So we can say that delta U is given to you as 200 joule. Delta U can you write NR delta T. Now 200 joule. NR delta T you can also write as what? P2 V2 minus P1 V1. We can write it as, because if I take this and again P2 V2 equals to NR T2 and take the difference, so it will become P2 V2 minus P1 V1. So from that equation we have write it as this P2 V2 minus P1 V1 200 joule. This is equation number 2 we got. Okay. Now, so let us find out the work done in the process. So we know that work done W is given by P dot dV, and let's say it is expanding from, or it is compressing from V1 to V2. Okay. Now, what we can do, you can put the value of P from the equation number 1 in terms of volume. So it is 2A by 3 root V dV. It's clear to everyone? P is equals to, we can take this root V in this side, so it will become 2A by 3 root V. Same thing we have written here. V1 to 2. Now, what we can do? We can take 2A by 3 as common because it's a constant quantity. No relation with the integration and differentiation. Integration V1 to V2, 1 upon root V dV. Now, what is the formula for 1 upon integration of 1 upon root x dx? It will be 2 root x. Directly remember, 2 root x. Okay, just twice the function which is given to you. So here what it will become? It will become 2 root v. Okay, so work done in this process will become 2a by 3 into 2 root v, v1 to v2. So we can say that 2a by 3 2 root v2 minus 2 root v1. We can take 2 common. It will become 2 times 2a by 3 root v2 minus root v1. Now we need to convert it into in terms of pressure and volume. How we can do that? If you put the value of 2a by 3, which is p root v, because this is the process equation. So for initial state, you can write it as p1 root v1. For final state, you will write it as p2 root v2. So you will put the value of 2a by 3 according to that. 2 times. If you multiply it with v2, we will take the process 2. So 2a by 3 we can replace with p2 root v2 into root v2. Same for that. P1 root v1 v. So what it will become? It will become p2 v2 minus p1 v1. Now we know the value of p2 v2 minus p1 v1. We have already got it. This one from equation 2. So it is given to you as 200 joule. Okay. 200 by, I think 200 it is given to you here. And one mistake that we have made, delta U is the NCV dt. Na? CV is 3 by 2 times of R. So this P2 V2 will become 400 by 3. Sorry for this mistake. So we will put The value of P2 V2 minus P1 V1 here is 400 by 3. So work done we have got is 800 upon 3 joule. So this is the work done in this process. So any kind of doubt, you can ask right now. Okay, in each and every step. Okay. Now the second question is the find molar specific heat in this process. The what is molar specific heat? So we know that Q is equals to NC delta T. This is the molar specific heat. Got it? Now Q, we don't know what is the value of Q. So what should the worry? Why should we worry? Q is equals to delta U plus W, delta Q. So it will become delta U is given to as 200. W is given, W you have calculated as 800 by 3. So it will become 1400 by 3, I think. Yes. 600 plus 800, 1400 by 3 joule. Okay. Now, C here will become what? Q upon N delta T. Now, N delta T, you can put the value from here. It will become this equation, this one. N delta T you can put from here. N delta T is 400 by 3 into R, because it is given to you that 3 by 2 nr delta T is 200. 3 by 2 nr delta T is 200. So n delta T we know. N delta T will become 400 by 3 R. Okay. Any kind of doubt? I hope it is clear to you. So C will be Q की value we have 1400 by 3. N delta T we have 400 by 3 R. This 3 and 3 will cancel out. 2 0 will cancel out this. So C will become here 7 by 2. This is the molar heat capacity or molar specific heat in this process. I hope it is clear to everyone. Any kind of doubt? Anyone? Darshana, JNV Bhavnagar, JNV Anand, JNV Ramnagar. Any kind of doubt, guys? You can ask right now. Okay. So move on to the next question. This one. So this is the previous year question of JEE Main, and directly from the formula, very important formula. Most of the question you will see from the RMS speed. Okay. RMS average speed. So one question you can definitely ensure from these three velocities, that is RMS speed or RMS velocity, या फिर RMS speed you will say, and the average speed or and the most probable speed. The most probable speed is not has been asked frequently, but yet there will be a chance. But RMS and average has been asked regularly. Okay, one question will be definitely ensure, definitely from that. So try to solve this question. The RMS speed of the oxygen molecule in a vessel at a particular temperature at 1 plus 5 by x, 1 by 2 times into V. 1 plus 5 by x raised to the power half into V, where V is the average speed of the molecule. The value of x will be. So solve this question, giving you 1 minute to solve this question. Okay. And also I'm giving you hint that VRMS is 3 by 3 RT upon M, and V average is 8 RT upon pi n. This. These two formula will be used in this question. Let's see who will crack this. So 7 guys is present here. Let's see who will crack it. I will clap for you guys. If you do so, I will clap for you. Come on, guys. You can do it. So anyone got the answer? Actually, my health is not so good. Okay. Suffering from fever from last 3 to 4 days. That is why my voice is a little low. Hope you understand. So anyone got the answer? A, B, C, or D? Anyone? Any guesses also? This will also work. Any guesses? Let's see who has the guessing power. Shiva, student of Jain Viramnagar. Okay. So meanwhile, you guys are solving this question. I'll also start solving this. Yeah. Any problem? Option D. 27 you are saying, na? Let's see. And very good, you have answered it. Keep it up. So RMS speed is given to you. VRMS is 1 plus 5 by x V average. So VRMS we have 3 RT by M. M is the molecular mass here. 1 plus 5 upon x. V average is root 8 RT upon pi M. Okay. Now, if you, this is also has a power half. So if you square all the terms, both the side, what you will get? It is 3 RT upon M, 1 plus 5 by x into 8 RT upon pi M. Okay. Now RT upon M and RT upon M will cancel out. And this will become 3 pi by 8 equals to 1 plus 5 by x. Now what you will do? You will take this 1 here. So 5 by x you will have as 3 pi by 8 minus 1. So 5 by x will become 3 pi minus 8 upon 8. 3 pi means 3 into 3.14. So it will become 3 for the 12 and 3 1 the 3, 4, 3 3 ja 9. Okay. So this will become 5 by x 9.42 divided by 8. Got it? So approximately, just a second, let me check the answer first. I'm not confirmed with this. Just a second. Okay. So instead of putting pi is equals to 3.14, we should put 22 by 7. That will make the question easier for us to solve. In terms of point, we can also do that, but then we have to guess it, the greatest integer. So 1 plus 5 by x is equals to 3 into 22, 8 into 7. Pi key value we have put 22 by 7, which is also given in the question. So 2 4 ja 8, 11 2 ja 22. So it will become 5 by x, 33 divided by 28 minus 1. So this will become 33 minus 28 will become 5. So 5 by x we have 5 by 28. 5 and 5 will cancel out. So x you have as 28. So student of JNV Ramnagar, you just missed it by 1. So no problem in that. Just try to be accurate. Okay. Silly mistake. You want to do silly mistake. I know that no one will willingly do this, but if you are having the silly mistake, do it on the rough notebook and all, but not in the examination hall. Okay. I definitely clap for you because you have attempted. So that is your reward. But try to be accurate. Okay. So I hope you understand it. Option C is the correct one. Now move on to the next one. Yeah. The same question, same concept we have. Now RMS speed is also given to you. The same question has been asked on RMS speed. And now try to solve this. If the RMS speed of chlorine molecule is 490 meter per second at 27 degrees Celsius, the RMS speed of argon molecule at the same temperature will be what? You have to answer it. The atomic mass of argon is given to you and molecular mass of chlorine is given to you. Okay. Why atomic and why molecular? Because argon is the monoatomic gas. So single molecule we have in the stable form. That is why the mass is being calculated in the atom term, atomic mass, because only single atom is there. But chlorine cannot exist in single molecule. It is the diatomic gas. So for diatomic gas, which means two atom of chlorine we have, so it will form what? It will form a molecule. So that is why the molecular weight or molecular mass of the chlorine is given to you. Okay, hope you got it. Now, try to solve this question. A very simple question, just to find the relation. What is the relation between the RMS speed and the other parameters, which is relatable in this question? Okay, so solve this question. Meanwhile, I am also solving it. So put your answer in the chat box. Okay, now RMS speed we know. Again, VRMS is nothing but square root of 3RT upon M. Now this M is the, for at monatomic gas it is atomic mass, and for molecular gas it is, although it is molecular mass of the weight, but for atomic gas we will take atomic mass and molecular mass are same. So atomic mass and molecular mass. Now we know that VRMS is directly proportional to temperature, square root of the temperature. But in this question, now, if you read it carefully, the RMS speed of chlorine molecule is at 27 degrees Celsius. The RMS speed of argon molecules at the same temperature, which means temperature relating the VRMS with temperature is, I think it has no point in this question because temperature is same. So you can say, oh, okay, तो temperature के साथ VRMS is directly varying with temperature. So temperature is same, so speed will also be same. But by looking at the option, you will definitely reject this conceptual building because no answer is 490, which means definitely we have to make another theory of that, and that is M, because here the weight are different. So we can say that VRMS is directly proportional to 1 upon root M. So VRMS of chlorine Cl divided by VRMS of argon equals to mass or the atomic weight of argon, atomic weight of. So if we put the value, argon will be 39.9 and it is 70 point. No, do the calculation. I am also doing this. You can approximate also the value. So it is 39.9 divided by 70.9. So this will become 0.56. And if you take the square root of this, so it will come out to be 0.74. Now, VRMS of argon will be, this will come downside here. So VRMS of chlorine divided by 0.74. Now, chlorine is given to you 490 divided by 0.74. So what you can do? Simply divide it, 490 divided by 0.74. Okay. So it is coming nearly about 651.7 meter per second. Okay. Nearly. Not saying the exact value. Now, got it? Everyone? So move on to the next one. I hope you get it. Any kind of doubt you can ask. This one. So this is a statement kind of question. The relation of being greater, equal to, or greater than equals to. So this question has also the favorite questions the examiner. Okay, because this question check your conceptual understanding. Now, the three vessel of equal volume contain gases at the same temperature and pressure. The first vessel contain neon monatomic, second contain chlorine diatomic, and third contain uranium hexafluoride polyatomic. Okay. Now arrange these on the basis of their root mean square speed and choose a correct answer from the option given below. Now we know that VRMS, okay, VRMS is square root of 3RT upon. Okay. Now this RT you can replace by PV. Okay. PV is equals to nRT for 1 mole. This will be PV. Now pressure is something that is not given here. Yeah. temperature and pressure is same. So you can either do it by this also. क्योंकि volume is also same. Equal volume, same temperature, same pressure. So it is 3 RT upon M. The only thing varies is M. Here to confuse you, the question has specifically mentioned that this is neon, which is monoatomic, chlorine, which is diatomic. So student will start thinking about that some of the factor will also come about the monoatomicity of the gases. Because neon is monoatomic, chlorine is diatomic, uranium is polyatomic. So they will start thinking that this atomicity will also play a role in this question. It is not like that. Have you seen anything in this question about the atomicity anywhere? No. Only if the temperature and R is constant for everyone, temperature is constant for all. Same. So, so the VRMS will only vary with 1 upon root m, which means the molecular weight of these. So we know that neon, it is 10 Ne. Neon is less heavy, mass of neon. You guys are studying chemistry as well. So mass of these substances or these elements, you will get to know. So neon has less mass than chlorine, and obviously it is hexafluoride, which means uranium, then fluoride, six atom with fluoride, hexafluoride. So that it is heavier than all, everyone. So this is uranium hexafluoride. So greater the mass, lesser is the VRMS because it is inversely proportional. So if mass will increase or the molecular mass I'm talking about is increased, the VRMS will decrease. So for uranium hexafluoride, which has the maximum weight, this VRMS will be minimum. Search where it is minimum in this question, in this. Then Cl, chlorine, is between, intermediate. So it has the VRMS greater than UHF, which is uranium hexafluoride, and less than the neon, because neon has the least mass in this. Okay, least atomic weight, minimum atomic. So neon has the greater VRMS from another atoms in comparison to the another atoms which is given to another gases which is given to. So VRMS for mono is greater than VRMS for dia is greater than VRMS of polyatomic. Okay, got it? So option B is the correct option. I hope you got it. Now move on to the next one. This is a very simple question. If you just know the relation and how to relate, how to extract the information. Now this one. So this is something which is new to you, not new to you. I have already told you about the concept of mixture. Okay. But not specifically the for temperature. What is the mixture of temperature of mixture? I have told you about the CV and CP of the mixture. Okay. Degree of freedom of the mixture. Number of moles the mixture. I have told you. Now, in this question, a gas mixture consists of 2 moles of oxygen, 4 moles of neon at a temperature T. Now, neglecting all the vibrational mode, the total internal energy of the system will be the what is the total internal energy of the system? And you have to neglect all the vibrational mode. So if you neglect the vibrational mode, only thing that is remaining to you is 3 by 2 RT type of thing. Okay. That too excessive factor will not come because vibration, due to vibration, two extra term will come, which is the potential energy of the system plus the kinetic energy of the system due to vibration. So that will not become here. Only the internal energy will come without vibration. Okay. So law of equipartition of energy you can also apply. Here the mixture is said to you. So we can definitely say it that U of mixture. Here we are told it about that U is equals to U1 plus U2. Noted. Now U is U of mixture. It is N1 CV1 T1 plus N2 CV2. Now T1 and T2 is same. So T you can take out. N1 CV1 plus N2 CV2. Now T N1 2 mole of oxygen. Yes. CV. CV you put according to the atomicity of the gas. Oxygen is what? Diatomic or monoatomic? Tell me in the chat box. Oxygen is diatomic or monoatomic? And do not write it completely diatomic. Only write D or M. So what is oxygen? Oxygen is, yes, I'm waiting for you. Oxygen is diatomic. Okay. So for diatomic, CV1 will be 5 by 2 times of R plus N2 means 4 moles of neon. We have previous in the previous question. Focus. Neon is monoatomic given to you. Okay. All the inert gases are the monoatomic gases. 4 into CV2. CV2 will become 3 by 2R. For monoatomic, the value of CV is 3 by 2. For dia, CV will be 5 by 2. Got it? For tria, it is 7 by 2. Just add 1. This will 2. This will cancel out. So it will become 5R plus 2, 3 is 6R. 6 plus 5 will become 11R. So this is the internal energy. Look how simple is this. But what if it is said that consider all vibrational mode also? Then you what will you say? What will you say? Then we know that half kb into T plus half kb into T will also add. And kb is nothing but R into Na. So if you ignore this Na, so RT and half RT plus 1 by 2 RT will also add, which is 1 RT also added. So if you consider the vibrational mode also, this will become 12 RT. Okay, simple. So I hope you got it. Have you got it? Student of JNV Ramnagar, Bhavnagar, JNV Anand. Any kind of doubt in this? Okay, if you got it in each and every question, if you got that, just put the message in the chat box that we have got it or clear sir, whatever the message do you like. You can put it in the chat box after every question. Okay. So this thing I am require I'll require from your side. Only the little thing. Okay. No. This one. Try to solve this question and this will be the last question of this session. So a cylinder contains hydrogen gas at pressure 249 kilopascal and temperature 27 degrees Celsius. What is the density of it? So this question is from NEET 2023. So try to solve it. And we know that ideal gas equation is PV is equals to nRT. Everyone, this is the ideal gas equation we have. Now, So what we can do, PV, because here mass is not given to you. Okay, mass is not given to you. Number of moles is not given to you. And density has been asked. So you need to convert this PNRT in terms of density and mass of the gas. So we know that N, number of moles. How you will find the number of moles? Mass, given mass divided by the molecular mass or atomic mass into RT. Now P is equals to small m upon V into 1 upon m RT. Thus mass upon volume will become density. So P is equals to rho upon m, capital M, RT. You can take this m this side, rho R T. So rho here will become Pm over RT. Now for hydrogen gas, we know that molecular mass of hydrogen gas is 2 gram, 1s2, 2 gram. So pressure is 249. Now, according to this, you need to put the unit. So temperature is degree Celsius, but in R, it is in Kelvin. So you need to convert the degree Celsius into Kelvin. You need to add 273. It will become 300. So option A you are saying. Yes, you are absolutely correct. Very good. Brilliant. Keep it up. Option A is the correct one. So P is 249. It is in kilopascal, so we need to convert it to Pascal. So 1 kilopascal has 10 raised to the power 3 Pascal. Then again, mass is 2 into 10 raised to the power minus 3 because mass is 2 gram. 2 gram. So we need to convert it into kg. So it is 2 into minus 3 kg. RT, R is given to 8.3 and T is 300. This will cancel it out 30 times. This will also cancel. So it will become 300 into 2 divided by 300. Okay. Yes, it is not 300, it is 30 here. So it will become 0.2 kilogram per meter cube. Okay. So this one is the correct one. And you got it very correct. GNV Ramnagar student. And thank you so much. Keep it up. Now, one of the question I need to ask you, and the poll is not working in this, so I'm asking you in the, you can put your answer in the chat box, and that is not related to your the question discussion and all. Now, in your schools, na, in your school, I have started with oscillation chapter. Okay, so in 11th class, and this is also for 11th. So in your school, I think oscillation chapter is not going. So you guys want a revision classes, crash course based on the chapters that we have covered, or you want to continue that? So first is the A option is the option A is we want to continue with current chapter. Current means oscillation that we are studying. Okay. Or option B, we want the crash course. Crash course, which is for revision. So your syllabus is over. So what do you want? Option A or option B? Because we are thoroughly studying the oscillation and wave, which is remaining for us. So it's up to you. Everyone I need to answer. Everyone. student of JNV Bhavnagar and JNV Anand, everyone need to answer it. This is not the questions. This is just the inquiry. Okay. Okay. So yeah, I will discuss it with my seniors, and then we will move according to your responses will also be considered. Thank you for response, JNV Bhavnagar and JNV Ramnagar. So we will be consider for that the responses of yours and our team discussions. So then we will let you know that from Monday onwards, what which classes do we have. Okay, either it will be a crash course revision or it will be the continuation of the current chapter because only two chapters is remaining, which is oscillation and wave. So yeah, so thank you guys for your responses in the question discussions and in this last inquiry discussion also. Thank you so much for being attentive and take care of yourself. Bye bye. Yeah, thank you so much.